Continuing our teardown of the Marantz PMD 740, in this section we're going to concentrate on getting the boards removed from this upper section of the case and reattaching them to the section below in such a way that it's kind of ergonomically feasible to... By the way, I got a comment recently saying, I ain't got no learning, I don't understand them long words you use. So what I mean by ergonomically is just like trying to find a layout of all the printed circuit boards, how you can put that all on a desk in a way so you can see everything and access everything you need to access and still be able to change all the trim pots to calibrate stuff. So let's start off with this board here. It's got the counter, all the digital control buttons on it and the main transport controls on it. So in order to make this video a little bit shorter for me, I haven't plugged in all the screws, but you can see that there's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 holes for screws. I've only got 5 of them in, which is probably all that's necessary. And they're going to be of this sort of 1 centimetre long-ish. I'm using my sort of bog standard, what's that, Phillips size 1 or 2, common household size screwdriver to remove those. With those screws removed, that'll lift out. So, key switch display PCB, that's what they're calling it. Sometimes, if these aren't working properly, you can scoosh some contact cleaner in there, blow it out with some compressed air, agitate it, maybe repeat the process a few times. Sometimes that'll get these working if they're not working already. Sometimes it can be good to reflow the solder on the back of these switches if they're not operating properly. By reflow I mean heat up the existing solder and add a little bit of fresh solder that can get around dry joints. Meter board over here, we've got 3 screws holding that in place. Same brass type of screw, with all 3 screws removed, and this will just lift out. One of these sides, these were coming out, a bit of plastic behind it. So, I mean, that's not too big a deal. If that comes out, then it'll just slot back on top. I mean, that's basically just, what's the word, a prism, a lens for the colour of these 2 colours of LEDs down here to light up the meter depending whether it's recorder or playback mode. And finally, while we're on this board, I'll discuss the door mechanism. Now, as you can see here, I've got a repair here. I did attempt to spin weld this plastic and it didn't take to it as well as the plastic of the Tascam cases. I've got a whole section on my YouTube channel splash page about spin welding. It's basically where you use high-speed drill friction with plastic dowel in the drill bit, and the heat melts the plastic of the receiving surface and of the plastic in the bit, and they combine, and so it's almost like a process like welding. So I guess this formulation of plastic is less suitable for that technique. It sort of went a bit bubbly and weird, so partly worked, and then I've shored that up with JB Weld, which is just a 2-part glue. I don't like using it because it takes so long to set. It takes about 24 hours to set properly. I mean, it's working fine again now. Pop, pop. But just because that repair didn't go as well as I might like it to have done, I'm not keen to remove these on camera, so I'll just talk about it. You can see that there's this same kind of brass screw on either side, 1 clip per side, also a pin that's built into the case that passes through the hole in this clip. And then here on the right side, as we look at it from the back, you can see this horseshoe shaped spring, and that's what's creating the spring mechanism. Did that just pop out? Oh my god, look, I just broke this again. How annoying. Right, I'll need to fix that. Anyway, this spring actually came from a Porter 1, so it's the same mechanism that's in there. And you can see that some of these buttons have broken as well. In this case I used spin welding. That's actually cut up bits of cable tie there to make that spring, and then I've shored it up with JB Weld. I guess I'll fix that with JB Weld, and this is broken a bit, so I've fixed that with JB Weld as well. Okay, so you've not identified any catastrophic electronic problems. You're not sure that the VUs are calibrated properly. You're not sure that you're getting a good match between the levels that you think you're recording the tape and what you're getting in playback, so you want to calibrate the levels of the record and playback amplifiers. What's the best way to set this up? The way I've been doing it is I've got the case with the power input and the power switch off to the right, so I'd be plugging in my power there, and it's still connected up in this corner. I've got the shuttle controls plugged in, but just dangling down here. I think for the purposes of calibration, the shielding doesn't matter, and this mixer board, everything's plugged in, but I'm just tipping it from the front, and it's basically hinging on these plastic standoff mounting posts here. The mixer's separate from the board below, and I've got the meters up here separate on a non-conductive surface, and plugged in the two places we unplugged them earlier, and obviously the heads and the control power cable here for the transport are plugged in. So at that point you can put in your test tape or whatever. You've got access to all your inputs and tape outs and everything you need to do at a calibration. The principles are going to be pretty much the same as what I'm demonstrating on models, including 244. 424 Mark III is probably the closest, maybe the 424 Mark II to the process. So refer to my calibration section of my YouTube channel if you want to see how to do that. This is just how to access the trim pots and the location of them. So then you can tip up under here, and these ones on the left use your playback and playback EQ trim pots, and they're labelled on the board. And that's your bias, which I'd probably leave alone unless you specifically had some kind of problem with weak, wispy sounding recordings or partial erasing. Your record level, that's the other main ones. Playback level and record level I'd always calibrate, and only really come to the other ones if I absolutely needed to. The other four that you see, 1, 2, 3, 4, that's the timing. And then the meter calibration is just off the side of each meter. So you just want all four needles to reach the same point given the same input signal there. So, you could use a very specific voltage coming out of a function generator, or you could just set your synthesizer, something that's producing a continuous tone which doesn't vary in amplitude, and if it's coming up to like -4 decibels in this one, make sure it's coming up to -4 decibels in all of them, and at least you'll know that the meters are giving you roughly the right reading. Set those first, then set the playback level, ideally using a test tape, but using a loud passage on a commercial tape would probably do the trick. And then it's an iterative process of making test recordings and checking that the recordings you thought you were recording it to, so say on the meters it says -3 decibels, it's like when it plays back, is it -3 decibels? If it's lower than that, turn the record amp up. If it's higher than that, turn the record amp down. So I'm glossing over the process, particularly the technical details, quite a bit there. I tend towards getting useful musical performance out of these as opposed to doing it absolutely technically perfectly. But anyway, that's roughly how I would set this up for calibration.